Hello, ladies and gentlemen. Today we're going to look at compositions of transformations. When two transformations are applied to a figure, one after another, the total transformation is a composition of transformations. A glide reflection is a translation followed by a reflection in a line parallel to the translation vector. Notice that the composition of isometries is another isometry, and that just means that they're congruent. That's what he ends up. That won't always be the case. You could have a translation and a dilation. You could have a reflection and a dilation. So understand that as well. There's many different kinds of transformations. All right, let's go look at some translations. All right, number one down here says to triangle XYZ has x6, 5, y7, -4, and z5, -5. Graph triangle XYZ and its image after the indicated glide reflection. Okay, well, first of all, I'm going to go ahead and plot the original at 6, 2, 4, 5. All right, so there's, excuse me, there is the point X. All right, so there's point X, approximately right there. Y is at 7, -2, 4. So there's Y. So X and Y. And Z is at 5, -2, 4, 5. There's point Z in the center of that box. All right, now I'm going to go ahead and use my straight edge, all right, to connect those points to form triangle XYZ. So we'll connect X to Y, X to Z, and then of course Y to Z. And there is the original triangle. Now, we're going to translate that triangle along this vector whose horizontal component is 1 and whose vertical component is 2, and then we're going to reflect in the y-axis. Okay, so let's make the rule. That's what I would do. I would say, okay, I'm going to make the rule with the intermediate step in it. All right, if we move along the vector 1, 2 here, we would get x plus 1, comma, y plus 2. All right, and now if we reflect that about the y-axis, the sign on the x-coordinate changes when you reflect about the y-axis. So that would go to -x minus 1, comma, y plus 2. All right, so that's the rule. And you can leave that intermediate step off. In other words, say, for this composition of transformations, that xy transforms to -x minus 1 for the x-coordinate and y plus 2 for the y-coordinate. Now we'll find the coordinates of x prime, y prime, and z prime. Let's start with x. To get the x-coordinate, we take the opposite of the x-coordinate of x, which is 6, and the opposite of that's -6, and decrease that by 1. And when you decrease -6 by 1, you get -7. And then we take the y-coordinate, increase it by 2, 5 plus 2, that will give you your y-coordinate, which is 7. Okay. Excuse me. Y, we're going to take that y-coordinate, take its opposite, which would make, of 7, make it -7, and decrease that by 1 would make it -8. And then take that x-coordinate and increase it, or y-coordinate, excuse me, -4, and increase it by 2 would make it -2. Now let's go to z. To take the opposite of the x-coordinate of z, the opposite of 5 is -5, and decrease that by 1 gives you -6. Take that y-coordinate, -5, and increase that by 2, that would give you -3. And now we're going to plot those points on the grid. Okay, -7, 2, 4, 6, 7 would be approximately right there for x prime. -8, -2 would be the coordinates for y prime, and -6, -3 would be the coordinates for z prime. All right, and then you can connect x coordinate x prime to, well, did I get z prime right? Negative 2, 4, oh, wait a minute. I don't think I got that x prime right. Negative 7 would be over here. That thing should be over here. That's what the problem is, not that point. So connect that point to z prime, x prime to z prime, and x prime to y prime, and then y prime to z prime. And there you go. Okay? All right. Let's go to number 2. In number 2, I'm going to plot the original first. All right, once again, x is 6, 5. 6, 5. Y is 7, negative 4. All right, and z is at 5, negative 5, which would be in the center of that box right there. Okay, and now I'm going to connect x to y, x to z, and then y to z as well to get the original triangle. All right, now I'm going to write my rule, and I think it helps to write that intermediate step. All right, if we translate along this this vector, we're going to get x minus 3, comma, y plus 4. And then if we translate that along the reflection in the x-axis, when you reflect in the x-axis, the sign of the y-coordinate changes. So the x-coordinate stays x minus 3. And the opposite of y plus 4, that just means you multiply it by negative 1. When you do, you get negative y minus 4. Okay, or the opposite of y minus 4. Now let's find the coordinates of x prime, y prime, and z prime. We'll start with x. So we need the x coordinate, which is 6, decreased by 3. 6 decreased by 3 is 3. Now we need the opposite of the y coordinate. Well, the opposite of 5 is negative 5, and then we decrease that by 4, which would be negative 9. All right, now let's go to the y coordinate. Take the x coordinate, 7, and decrease that by 3 would give you an x coordinate, 4. Take the opposite of this y coordinate, the opposite of negative 4 is 4, and decrease that by 4, and 4 decreased by 4 is 0. Excuse me. All right, now we'll go to z. Take the x coordinate, 5, and decrease that by 3, would go to a 2. All right. Then take the opposite of that y coordinate, which is 5, and decrease that by 1, 5, by 4, excuse me, would give you a positive 1. If you take the opposite of that y coordinate, opposite of negative 5 is 5, and decrease that by 4, that gives you positive 1. Okay. All right, now that we got those points, we can plot them. So 2, 1, all right, 4, 0. I need to label those points. Z, and 4, 0 was y prime. And then 3, negative 2, 4, 6, 8, 9 would be in the center there. There's y prime. And then you can connect y prime and z prime. Y prime with, z prime. This is z prime. Hold on. That's 3 negative. That's supposed to be x prime. There we go. X prime. X prime to y prime. And then y prime back to z prime. And there you have translated 3 units to the left, 4 units up, and then reflected about the x-axis. All right, let's move on. Next, let's plot the original. All right. 7, negative 2, 4 is point x. Okay. X is at 7. Is it 7, 4? Oh, 7, negative 4 is y. Excuse me. There's y. I knew something wasn't right. Okay. X is 6, 2, 4, 5. That's point x right there. And then z is 5, negative 2, 4, 5. There's point z. All right. So then I'll connect x to z to start with, and x to y, and then y to z to get the original triangle. Okay, now let's write the rule. The rule for this composition of transformations would begin by increasing the x-coordinate by 2 and leaving the y coordinate what it is. Now, if you reflect about the line y equals x or x equals y, it's the same thing either way, you reverse the roles of these. So this rule becomes xy changes to y comma x plus 2. That's what the rule would be. Now let's find the composition of transformation coordinates. The coordinates for x prime, y prime, and z prime. Okay, so we need the y coordinate of x is 5. And then we want the x coordinate increased by 2. If we take that x coordinate 6, increase it by 2, you'll get 8. For the y coordinate, x coordinate of y prime, we want the y coordinate of y, which is -4. Take its x coordinate 7 and increase that by 2. 7 increased by 2 would be 9. All right, the y coordinate of z, -5, becomes the x coordinate of z prime. And the x coordinate of z, 5, increased by 2, which is 7, becomes the y coordinate of z. All right. Now, let's plot those points. 5, 8, 2, 4, 6, 8 would be approximately right there. That would be the approximate point for x prime. All right. -4, 2, 4, 6, 8, 9. That would be the coordinates of y prime. And then -5, 2, 4, 6, 7 would be the coordinates of z prime. And then you can connect those. Let's connect x prime to y prime first. X prime to z prime. And then y prime to z prime. And you're finished with problem number 3. Okay, let's do that last one. All right, I'll plot the original points at 6, 5 for x. All right, y is at 7, -4. 7, -4 are the coordinates for point y. And 5, -5, 2, 4, 5 are the coordinates for point z. All right, so we'll connect x to z, x to y, and then y to z to get the original triangle. Okay, now we'll write the composition rule. The rule would say that if you moved along this translation vector, that you would get x minus 1 for the x coordinate and y plus 3 for the y coordinate. And then if you translate that along, reflecting the x-axis, if you reflect in the x-axis, once again, the sign of the y-coordinate changes, but the x-coordinate stays the same, and that would be -y minus 3. Okay, so there's your rule for the composition of transformations and how we got it. Okay, all right, now let's find the coordinates for x prime, y prime, and z prime, respectively. All right, let's start with x prime. We want the x coordinate decreased by 1. And if we take that x coordinate, which is 6, and decrease it by 1, we get a 5. We want the opposite of the y coordinate, opposite of 5 is -5, and then decrease that by 3 would be -8. All right, now we want to take the x coordinate of y, decrease it by 1, so 7 decreased by 1 is 6. And then the opposite of that y coordinate, +4 decreased by 3, +4 decreased by 3 would be 1. All right. And now, excuse me, the x coordinate 5 decreased by 1 would be 4. All right. And the opposite of that y coordinate, opposite of -5 is 5, decreased by 3 would be 2. And now you've got your coordinates of these points. You can plot them. Okay, let's do. All right. 5, -2, 4, 6, 8. So there is point x prime. 6, 1, right there, approximately, is y prime. Okay, and 4, 2 is z prime. And then you can connect x prime to y prime, x prime to z prime, and then y prime back to z prime. And voila, you have finished the graph of that composition of transformations. Okay, please turn your page. All right. All right, those were all in the coordinate plane. Now we're going to look at some that are not in the coordinate plane. All right. We're going to talk about what happens when you do some of these. If you copy, well, we're not going to copy because it's already there. We're just going to reflect this figure P, this pentagon, in line A and then in line B. And then we're going to describe a single transformation that maps this figure, this pentagon, over. Okay. Well, I'm going to do it real quick. I'm going to say, okay. Excuse me. I only need to reflect 4 points, excuse me. All right. And I'm going to reflect that upper one first. Okay. All right. So if we reflect across that point across A, it would be out there somewhere. If we reflect that point right there, it would be out there somewhere. And then these two, I believe, are on the same line, because if I line them up, my protractor's flipped over. I would get 2 for 1 on that one, I do believe. Okay, so those rays will allow us to reflect all of those points. Okay, now let's start with that upper one. That upper one appears to be about that distance to the left of line A. When you reflect it about that point, it will be over here. Okay, uh-oh. Let me rotate my paper so I can locate that pretty easily. I'm going to turn it over this way. Can you see it? Okay. No, you can't see it. Yeah, you can see it. There you go. Okay. All right, so if I measure that distance there and I come and mark that off over here, it's going to be about right there. Okay? All right, now I'm going to next measure this one. This will come from the top down. I'll measure that one next, even though I'm going to be opening and closing and whatnot, but that's okay. All right, and then I'll do the shortest one, or let's do the longest one. Okay, the longest one first. Okay. And you can measure those. If you can see to measure that, I can't do it. You guys know. Can't see that well, so I'm going to use my little compass here. Probably just as easy. Okay, I now have those points reflected. Okay, all right, and I'm going to use my straight edge to connect them. Okay, so I can connect those 2 points right there. Okay, those two. All right. Excuse me. All right, connect these two, connect these two, connect those two, and then connect these two. So that figure would look like that right there. Okay, all right, and then you're going to reflect each of those. That one looks like I missed it by a little bit. Let's see. Well, I might have missed that last one. I can't see. All right, now we would need to reflect each one of those. This one's already on the line perpendicular to line B. I would need to do this one right here. Okay, come down through there. I would need to reflect that one across line B. Reflect that one across line B, and then reflect that one across line B as well. Okay, all right, so then I'm going to rotate that to the right because it'll be easier for me to reflect those points. Okay, all right. So if I reflect that first point right there across that line B, it will stay on line B, and it will be located about right there. Okay, the next one is on line B. These two are actually on line B, so I really only needed these other two. Okay, so this one to line B is right there. Okay, there we go. And then this one right here to line B is right there. All right. And one more thing. All right, wait a minute. I need to reflect those other two. I didn't do that. I'm going to go back and reflect those other two that are on that line. They're just the same distance, it looks like. Okay, so where is that point? Oh, I got that one. It's right here. I'm going to measure that point 2B. Did I measure that? I didn't measure that right. That point right there needs to go down there. I can't see. All right. That first arc's not where I need. My point I'm going to need is over here, is that point, not that intersection. I didn't measure the distance from that point that's on line A down to line B correctly. It should be there. Okay, now I can go back and measure these 2 points. They're about that far on that line right there. I knew it wasn't adding up. And I think my compass is a little messed up, but we're close enough. We'll be okay. All right, so now I've got all those points. Okay. All right. I know that's not right. That thing's way too far over. It should be more like right there. Those points should be a little higher than when I put them. Those two. All right, and then that thing comes down. Okay, that one's good enough. Okay, and then this one's going to come down to here. Okay, and then down to here, and then back over to there. And what you've done is when you reflect across intersecting lines like that, it ends up being a rotation, okay? All right, it ends up being a rotation, 180-degree rotation is what it amounts to. All right, if you were to rotate that figure, it would rotate 180 degrees. Okay, let's go to number 6 next. Now, I'm going to tell you that that thing's so hard to rotate. There's so many little points. There's how many? 1, 2, 3, 4, 5, 6 up there, 12. 12 points, and I can't see well enough to do that. I would tell you that if you reflected it in line A first, it would go over here, and then in line B, it would go up here. And if it did, it would look like this right here. Look a lot like, let me make that a little bit longer, like that right there. Now, what that really is this. It is a rotation twice this angle measure in here, okay, about point Q, okay? This will end up being a rotation 2 times 50 degrees about the intersection of the two lines, of line A and B. The intersection Q is what it will be. All right, now let's go do number 7. We're going to reflect, let's call it triangle A, B, C. First about A and then about B. Well, to do A, you only have to do 1 point. That's B. So I'll line up B, perpendicular to A, line A. I'll draw a ray across. Somewhere on that ray is point B prime. Okay, all right, and I can locate it there by measuring with my protractor, or with my compass, either one. I could measure, or ruler, all right. I'll measure that same distance across line B, and now I have all 3 points for that reflection. This would be point B prime, this would be point C prime, and this would be point A prime. So I can connect A prime to B prime, B prime to C prime, and there's no need connecting C prime back to A prime because that line segment already exists. All right, now we're going to reflect A prime, B prime, C prime about line B next. All right, so let's line up A prime perpendicular to line B, okay, and draw a ray. All right, line up B. Oh, well, B's already there. I don't have to do anything for B. All right, let's do C. All right, so somewhere down through there will be C double prime. Okay, all right, and now I'm going to measure from A prime to line B. Okay, let me do that. From A prime to line B is that distance. I'm going to mark that off on the other side because that will let me find A double prime. Okay, that's that point right there. I think C prime is the same distance. Yes, it is, which allows me to locate point C prime, double prime, excuse me. And now all I need to do is reflect point B prime. All right, it's that far from line B, and if I measure that and mark it off, I now have all 3 points that I need. This one is A double prime, if you like. This one is point B double prime, and this point right here is point C double prime. And now you can connect A prime to B, A double prime to B double prime you can connect B double prime to C double prime and C double prime back to A double prime. And as you can see, if you take the original, here's the original, and here's the one reflected about those parallel lines. It is a translation, okay? You just physically pick it up and slide it from A toward B, and it will always be, by the way, if this is X units apart, it will always be 2X units, okay? So when it says describe it, so triangle ABC is translated, all right, 2X units from line A toward line B. That's what you always get anytime you reflect to a figure, excuse me, about two parallel lines. All right, now this next one over here, I will tell you is a, excuse me, we're going to reflect about A. Well, if you're going to do this circle, what you might want to do would be to do the center. If you could locate the center, which I'm going to say is point C, okay, all right. If I could locate that center, all I need to do is rotate that center, and I might need one more point on the circle to get a radius. I'll put another point on there so I can get a radius. If I've got those two quantities right there, I can reflect that about that center, first of all, about line A, and then about line B. Okay, all right, now, let's do that. Let's take that center and reflect it about line A first. Okay, so somewhere, let me line up from C perpendicular to line A. Somewhere over there is going to be C prime. All right, and the way I locate it is I measure from C to line A. All right, and it looks like I'm about there already, so we'll just put it right there. Okay. All right, so there would be C prime, that point right there, C prime if you like. And now I'm going to draw a line from C prime, all right, perpendicular to line B. So line up C prime, rotate your protractor so that it's perpendicular to line B, draw a line across, and then measure the distance from C prime to line B, and it's a little less than we had before, okay, all right, and then mark off that distance on that line, or that ray, and now you have located point C prime. And that will be the center of the circle that is reflected about point line A first and then about line B. Okay, and now all we need is that radius on our compass. All right, so I'll take my C, measure my radius. There's my radius, okay? And then from C double prime, I will draw that circle, okay? All right. Now, a minute ago, we talked about reflecting across intersecting lines being twice the angle. Well, it might be that we need twice the angle that it doesn't lie in. That might be better, okay, in this case, because two of these would be, it's going to be a rotation about this, but if you were to draw that radius and that radius, that is, I believe, if we subtract this 125 from 180, that would be twice that angle right there. So I think this would be a 110-degree rotation, and let's call that about point Q. Rotation about point Q. All right, if you have questions, please give me a call, show up in the Google Meet, email me, whatever you need to do. Thank you. Have a good day.